Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. Today we have set our hearts to solve a theory paper, and for this purpose we have selected October-November 2022 2-2 paper. This paper 2 belongs from the Zone 2 or the Variant 2. The time allowed for this paper is 1 hour and 45 minutes. So let's start this paper. So Cambridge O Levels, Cambridge Assessment International Education, October-November 2022, 2-2 paper, 1 hour 45 minutes. We call this paper paper 2, theory paper. And here we go. The total marks for this paper, there are 75. And here is the first question. He says that a train travels along a straight horizontal track. At time t equals to 0, the train passes through station P at constant speed without stopping. The driver applies the brakes 70 seconds before reaching the station Q. The train decelerates. Figure 1.1 is the speed time graph for the train from t equals to 0 until it stops at the station Q. So here it passes from the station P and it do not stop. It continues moving with a constant speed at t equals to, I think, how much? Yeah, and 70 seconds before. So this is the Q. So before it's 70 seconds, it applies brakes and it slows down, and here it stops. On the y-axis, we have speed in meter per second, and on the x-axis, we have time, which is in seconds. So here he says train passes through the station P. Here he says train reaches the station Q. So this is the speed time graph of that question. He says using the figure 1.1, determine the distance between P and Q. So you have to find out the distance between P and Q. So the distance between P and Q, this is a speed time graph, and the area under the speed time graph is equals to the distance traveled. This is trapezium. This is the height, and this is one parallel side. This is the other parallel side. Or you can draw a line here and you can divide this figure into two parts. This will be rectangle and this will be a triangle, and find their areas and add them up, and that will be equals to the distance traveled. Okay. So distance traveled will be, I have divided in two parts. One is rectangle, the other one is triangle. Area 1 plus area 2. Area 1, which will be a rectangle, that will be length into width, and the length is 56 and the width, that height is 77, plus the next figure is a triangle. Its area will be 1 by 2 into base into height, and that will be 1 by 2 into 70 into 77. So just enter these values. This will be 7,007 meter, and when I write it in, I will round it off. It will be 7,000 meter. 7,000 meter. 7,000 meter is the right answer, sir. The marking scheme is on your screen. That's the solution. Question number 1, B part. He says the mass of the train is 3.8 expo 5 kg. If first portion is determine the deceleration of the train in 70 seconds before it stops at the station Q. So now we want to find out the deceleration. This is the diagram. So it's a speed time graph. So in the speed time graph, the gradient is equals to the acceleration or deceleration. So I note down the coordinates of this point. This is 56,77. I know this point. And this is, I think, 126,0. Okay. So just note down 2 points on that line, which is coming down on the speed time graph, 56,77 and 126,0. The gradient, find the gradient. You know the formula for the gradient is y2 minus y1 divided by x2 minus x1. That will be v2 minus v1 divided by t2 minus t1. So the acceleration will be 0 minus 77 divided by 126 minus 56. And that will be minus 77 by 70. And that will be minus 1.1 meter per second square. Because he used the word deceleration, that's why when I will write my final answer, I will not write the negative sign because deceleration means negative. 1.1 meter per second square. This is the solution. And here we go. Calculate the resultant force on the train as it decelerates. You know, we know the deceleration, we know the mass of the train, so very easily I can find the resultant force. The resultant force will be equals to F equals to ma, Newton's second law of motion. So F is equals to ma, the mass is 3.8 x per 5 kg. The acceleration, which we call the deceleration, is basically 1.1 meter per second square. Just multiply them. You get 418,000. When you write it in the standard form, it will be 4.2 x per 5 Newton. 4.2 x per 5 Newton. So our answer is right, sir. The marking scheme is showing up. Question number 2, he says the foundations that support a building are long concrete cylinders that are pointed at one end. A pile driver is a machine that forces the pointed concrete cylinders into the ground. Figure 2.1 shows a pile driver. Okay. So this is the heavy block. This is the pile driver. These are those concrete cylinders. So it is dropped on them. So when it drops, it goes into the ground. Okay. A heavy block of mass 2.9 x per 4 kg is lifted into the air, then dropped onto the top of a concrete cylinder. This forces the cylinder into the ground. Figure 2.2 shows the heavy block. The block is 2 meters tall and has a cross-sectional area of 1.8 meters square. Calculate the density of the material used to make the block. So I can find the volume of this block. You know, the volume will be base area multiply the height. That's the formula for the volume of the prism. Base area, which is 1.8 meters square. Height means the distance between the two bases, and that is 2 meters. So we can find the volume of this block. We already know the mass of this block. This is given here. And I can find the density. Density is equals to mass divided by volume. So the volume of the prism will be cross-sectional area multiplied the length of the prism. That is 1.28 multiplied 2, and that will be 3.6 meters square. Density is mass divided by volume. The mass is 2.9 x per 4 kg. And the volume is 3.6 meter cube. By mistake, I wrote here. See a mistake. I got a mistake. Because this is a volume, so this is supposed to be cube. Okay. So, and it will be 2.9 x per 4 and kg divided by 3.6 meter cube. And when you divide them, you get 8055.55 kg per meter cube. When you write it in the standard form, it will be 8.1 x per 3 kg per meter cube. 8.1 x per 3 kg per meter cube. Here we go. So this is the form. This is the marking scheme. This is the answer. This is the solution. And we go to the next question. Question number 2 is B part. He says the pile driver lifts the block from the top of a concrete cylinder through a height of 0.80 meter. The gravitational field strength G is 10 Newton per kg. Calculate the gravitational potential energy gained by the block. You know the gravitational potential energy? It is mgh. mgh. We know all these things. So very easily I can calculate. The gravitational potential energy gained is equals to mgh. The mass is 2.9 x per 4 kg. The g value in this paper we are taking as 10 Newton per kg. And the height it was lifted, that is 0.8 meter. So when you do this, when you enter this in your calculator, you get 232,000. And in the standard form, it will be 2.3 x per 5 joules. 2.3 x per 5 joules is the right answer. This is the solution. Question number 2, part B, portion 2. The block is then dropped from the rest onto the top of the concrete cylinder. Calculate the speed of the block just before it hits the concrete cylinder. So when it is about to hit the concrete cylinder, the kinetic energy in it will be equals to the loss in the gravitational potential energy. So the gain in the kinetic energy will be equals to the potential energy, which will be lost. And we already know the potential energy. So gain in the kinetic energy will be equals to the loss in the gravitational potential energy. So the gain in the kinetic energy, you know, the formula is 1/2 mv square equals to loss in the gravitational potential energy is 2.3 x per 5. So 1/2 into 2.9 x per 4 into v square is equal to 2.3 x per 5. So take this 2 to the other side, take 2.9 x per 4 to the other side. So you will have v square equals to 2 multiply 2.3 x per 5 divided by 2.9 x per 4. This is what you will enter in your calculator. So v square will be equals to 15.862. Take square root on both the sides. You will get 3.983 meter per second. When you round it off, it will be 4 meter per second. 4 meter per second is the right answer, sir. Figure 3. Figure 3.1, this is question number 3. Figure 3.1 shows a man standing underneath an outdoor heater on a cold evening. So here we have a metal hood, and this is shiny surface, the red hot metal screen. The man is standing under this heater. So he has this black colored pullover, and this is the gas cylinder here. Gas in the cylinder at the base of the heater is the fuel for the heater. When the heater, gas in the cylinder at the base of the heater is the fuel for the heater. When the heater is operating, the gas travels to the top of the heater where it burns. State the form of energy stored in the gas that is transferred by the heater. So the gas has the chemical potential energy. You only have to state the name. The gas will have the chemical potential energy. The gas will have the chemical potential energy. Our answers are right. Okay. Then question number 3 is B part. A metal screen surrounding the burning gas is heated by the burning gas until it is red hot. The hot metal screen warms the man who is standing underneath it. Describe how the thermal energy in the red hot metal screen is transferred to the man and how it warms him. You see, when that screen will become red hot. Okay. When this screen will become red hot, and here we have the shiny surface, it will give out infrared radiation, and when it will give out infrared radiation, and because of this shiny surface, the infrared radiation will be reflected, and it's placed such a way that it will be reflected downward, and it will reach the man, and the man will absorb that infrared, and his temperature, his body temperature will rise. He will feel warm. So let's read the statement again. Describe how thermal energy in the red hot metal screen is transferred to the man and how it warms. Red hot metals give out infrared radiation. Infrared travels downwards towards the man. The man absorbs infrared. His internal energy increases. This is my answer. Radiation or infrared radiation mentioned, or radiation and infrared travel to the man. energy infrared radiation absorbed by the man, pullover or travels in straight lines or travels at the speed of light or increases man's internal energy. Okay, the next question is, at the top of the heater is a metal hood that has a shiny lower surface. Explain why this makes the energy transfer from the metal screen more efficient. You see, this shiny surface. This shiny surface, all the infrared rays which will go in the upward direction, they will from this shiny surface reflected, because the shiny surface do not absorb the infrared. It is a very good reflector of the infrared radiation, and after reflection they will be directed towards downward where the man is standing. So it reduces the loss of the thermal energy to the surrounding, and it increases the heat absorbed by the man or heat traveling towards the man. So it makes the heater more efficient. Shiny surface is a bad absorber of infrared. It is very good reflector of infrared. Amount of energy absorbed by hood is very small. Most of energy is directed towards the man standing under the hood. So you see, this will make this more efficient. Shiny surface reflects radiation to the man, less energy escapes or more thermal energy reaches the man. Okay, so write this sentence also, that the waste energy will be reduced. Okay, question number 3, and we are on its B part, and we have done the second part. Now we are on the third part. The air temperature decreases, and the man puts on a black pullover. Explain one way in which wearing a black pullover helps to keep the man warm. Okay, so when you wear the black pullover, you see the black pullover is of black color, so it is a very good absorber of the infrared. So the black color will absorb more infrared. And another way can be that because you are wearing the pullover, and that will trap the air between the pullover and the body of the man, and that also reduces the heat loss from the body of the man, and he will feel warm. You only have to write one reason. Okay, so I have written that reason. The black pullover, due to black color, is a very good absorber of infrared radiation, so more energy is absorbed by the man. Okay, so then black surface is a good absorber, poor reflector of the infrared, more thermal energy absorbed or more thermal energy transferred to the man. Or the trapped air had reduced convection, air poor conductor, air is a good insulator, less thermal energy lost from the body of the man. Okay, we have written this first one, but I explained you the second one also. Okay, so we are going to the next question, and it's a 3 marks question. Question number 4. So question number 4 is, a sound wave traveling in air or water contains compressions and rarefactions. Describe an experiment to show that a medium is required to transmit sound waves. You may draw a label diagram if you wish. So here we have to prove that this is the bell jar experiment. In this, we take a bell jar, which is basically a glass jar, and it's one end is opened, this end is opened, and this one is basically closed. We pass through the wires, 2 wires from here. We put a cork in this hole, and with these wires and the threads, we have here an electric bell, and this bell jar is put on a table, and here we have a hole through which we connect a vacuum pump with it. On these rings we put some grease to air seal it. We seal this with the grease, so no air can come in, no air can go out from these springs. And when we switch it on, the electric bell, you can see this hammer. It will collide, it will strike this gong, and you will also hear the sound of the bell. Then keep ringing the bell. You will see the hammer striking the gong, and then switch on the vacuum pump. And as the vacuum pump will start switching out the, you know, the air from it, you will see that the hammer is striking the gong, but the sound which you will hear, that will gradually become fainter and fainter and fainter, and eventually what will happen, there will be no sound. So when all the air from this bell jar is sucked out and there is no air around this electric bell in the bell jar, you will see the hammer striking the gong, but you will not hear any sound, because the sound needs medium to travel. So if there is no medium around it, the sound waves, which are longitudinal waves, they cannot travel. So this is our experiment which you can do. I have written this. So this is a 3 marks question. Describe experiment to show that a medium is required to transmit sound waves. You may draw a label diagram. So here we go. So here I have drawn. So this is that bell jar, this is that cork, and these are the wires and the threads. This is the electric bell, this is the hammer, this is that gong on which the hammer strikes. So here I put some grease, and this is that hole in the table, and from through it a vacuum pump is connected so the air can be sucked out. So this is the diagram, and I've tried to make that diagram. Place a bell jar on table. Put grease under brinks of the bell jar to seal it so no air can escape or enter into bell jar. Switch on electric bell hanging in the bell jar. Bell rings, hammer can be seen striking the gong. Bell can be heard. Switch on vacuum pump. Gradually, the sound of bell will gradually faint. After some time, hammer can be seen striking gong, but no sound of bell will be heard. It shows when there is no medium, sound waves cannot travel. This is my answer. Hopefully you understand. And this is the marking scheme of the equipment. We have to show the equipment, we have to show the action, we have to show the observation. I hope you can write a better answer. So this is the answer which I have written, made the diagram, then this paragraph, and then this paragraph. You can pause the video, you can take time with that question. Okay, question number 4b part, he says, when a sound wave passes through air or water, the molecules of the air or water move. Describe the motion of the molecules due to the sound waves. You see, when the sound waves travel, the sound waves are longitudinal waves. So the disturbance in the medium they create, the particles of the medium vibrate about their mean position parallel to the direction of the sound wave. So this is my answer. It's molecules of medium vibrate about their mean position parallel to the direction of the sound wave. Question number 4b part, vibrate parallel. Okay, so our answers are right. Okay, question number 4b part, he says, describe what is meant by a rarefaction. You see, a rarefaction in the medium through which the longitudinal wave is passing is where the particles of the medium during their vibration motion are furthest from each other and the pressure is lowest. That region is called rarefaction. Rarefaction in a sound wave is region where particles of medium are furthest from each other and pressure is lowest. Point molecules are further apart than average, or point where pressure density is lower than average. Okay. Or density is, yeah, I use the word pressure, you use the word density also. Okay, so question number 4D part. The figure 4.1 shows a dolphin, and the question is, the range of audible sound frequencies for the dolphin is 75 hertz. A 140,000 hertz in water. The speed of the sound is 1500 meter per second. Calculate the smallest wavelength of the sound in the water that the dolphin can hear. Okay, so the smallest wavelength. We are not only interested in wavelength, but the smallest wavelength. Okay. This is the smallest frequency. This is the highest frequency. The speed is constant. So let me show you my solution. V is equals to F lambda. That's the wave equation. And lambda will be equals to V divided by F. We want the smallest answer of the F. The V is constant. So the F should be largest. So this division give you the smallest answer. So the velocity is 1500 meter per second. And the largest frequency is 140,000. When you divide them, you get 0.0107143, which is 1.1 expo minus 2 meter. 1.1 expo minus 2 meter is the right answer, sir. So this is the answer, sir. I hope you understand. And now we are going to the next question. He says the power supply in a circuit is made from several cells, each with the same electromotive force, EMF. The cells are connected in parallel. Explain what is meant by electromotive force. Electromotive force is the amount of work done by the cell to move unit charge in a closed circuit. Another definition is the amount of chemical potential energy converted into electric energy when the unit charge flows through the cell. So I have written the second one. You can also write the first one. Amount of the chemical potential energy converted into electric energy when unit charge flows through the cell. Or I told you, you can write the amount of work done by the battery or cell to move unit charge in a closed circuit. Question number 5A part, our answer is right. You can see the marking scheme. You can pause the video. B part, question number 5, state one advantage of using several cells in parallel rather than a single cell as the power supply. You see, when you connect cells in parallel, their life becomes longer. If one of the cells exhaust, the other ones continue providing the electric energy. Life of cells become longer. So it lasts for a longer. The marking scheme is showing up. Our answer is right. There are other options also available. You can write them. Okay, question number 5C part. He says the power supply is connected in series to a resistor of resistance 4,000 ohm and a thermistor. There is a voltmeter in parallel with a resistor. Figure 5.1 is the circuit diagram. So here is a fixed resistor 4,000 ohm. There we have thermistor whose resistance depends upon the temperature. And if the temperature rises, resistance decreases. If the temperature becomes lower, its resistance becomes higher. The voltmeter is connected across the fixed resistor. The temperature of the thermistor increases. Explain what happens to the reading on the voltmeter. This is called, I want the red one. Okay, this is the R1. Okay, and this is, if you remember the article of the potential divider, and this is called the V out. And this V out we have taken from the R1. Okay. So this is the V out. And this is called the voltage of the battery. And state what happens to the reading on the voltmeter. You see, when you will increase the temperature, this resistance of the thermistor that will decrease. So the whole circuit's resistance will decrease. Due to that, a larger amount of current will come out of this battery. So if you observe, a larger amount of current will flow through this. Okay, so if you pay attention to R1, which is the fixed resistor, its resistance is still the 4,000 ohm, and now a larger amount of current is flowing through it. And we know that V is equals to, V is equals to what? IR If the R is still the same, but the I value has increased, that means the voltage drop across this will also increase. It's a 3 marks question, and I hope you understand my explanation. Okay, so question number C and question number 5 is C in the first part. And he says, as the temperature increases, resistance of thermistor decreases, total resistance of circuit decreases. Due to this, current from the power supply increases. Resistance of fixed resistor is constant. Current through it has increased. So voltage drop across it increases because V is equals to IR. So reading on the voltmeter will increase. So I hope you understand. This is the marking scheme. This is a 3 marks question. I hope you understand. You can pause the video if you need more time with this marking scheme. This is the solution. Okay. He says the EMF of the power supply is 1.5 volt. Calculate the reading on the voltmeter when the resistance of the thermistor is 800. You remember the potential divider formula, the V out, and V out here is from the R1. So that formula will be R1 and divided by the total resistance, that is R1 plus the R2. That's the potential divider formula, very famous formula in your textbook. And you multiply it with the voltage of the battery. Okay. So if you are taking this V out from R1, so the V out will be R1 divided by the total resistance multiplied the voltage of the battery. So just put these values. The R1 is 4,000 ohm, the R2 is 8,000 ohm, and you can find it. So here we go. It will be 4,000 divided by 4,000 plus 8,000. That will be 12,000. Multiply the voltage of the battery, that is 1.5 volt. And when you do this on your calculator, you get 0.5 volt. So the reading on the voltmeter will be 0.5 volt. I hope you understand. This is the solution. And here we go. Question number 6, he says the primary coil of a transformer is connected to the main supply. The voltage of the AC main supply is 240 volt. The figure 6.1 is a diagram of the arrangement. So here we have a transformer. This is the primary coil. This is the secondary coil. The primary coil, here we have the input of an AC supply, and that the voltage is 240 volt. And here we have the secondary coil. He says, explain why our voltage is produced in the secondary coil. It's a 3 marks question. Why? You see, you have connected the primary coil with alternating current. When the alternating current flows through this primary coil becomes electromagnet. So it will have its north, its south. And because the direction of the alternating current periodically changes, that's why the polarity of this electromagnet will be also continuously, periodically changing. So its magnetic lines through this iron core will pass through the secondary coil. And when their polarity of this electromagnet will change, the direction of those electromagnetic lines will also change. They will flow like this, then they will flow like this. So the magnetic flux of this primary coil is periodically changing direction-wise, magnitude-wise. And that magnetic flux through the iron core is passing through the secondary coil. So through the secondary coil, the passing magnetic flux is changing. So due to that changing magnetic flux, the EMF is induced in the secondary coil. AC supply is connected to primary coil. Magnitude and direction of magnetic field formed on primary coil changes periodically. This changing magnetic flux through iron core passes through the secondary coil. Due to changing magnetic flux, EMF is induced in the secondary coil. It's a 3 marks question. Marking scheme is showing up. This is my answer. He says there are 5,600 turns on the primary coil of the transformer and 350 turns on the secondary coil. calculate the output voltage of the transformer. You see, output voltage means the voltage of the secondary divided by the voltage of the primary. That's the formula, will be equals to the number of turns in the secondary divided by the number of turns in the primary. So this is the formula I'm going to use. The number of turns in the primary, they are 5,600. Number of turns in the secondary are 3,500. The voltage in the primary, that was 240 volt. Voltage in the secondary is the question. Very simple, straightforward, numerical. Here we go. Voltage this secondary divided by voltage primary is equals to the number of turns in the secondary divided by the number of turns in the primary. So the voltage in the secondary divided by 240 equals to 350 divided by 5,600. So the voltage in the secondary will be 350 multiplied 240 divided by 5,600, and that will be 15 volt. 15 volt. 15 volt. 15 volt is the right answer, sir. That's the solution. Then the question is, the output of the transformer is connected to 90 watt filament lamp which operates at normal brightness. Calculate the current in the lamp. You know the power, the formula for the electric power is equals to I and V. The power is given here, and I know the voltage, that is 15, I think 15 volt. Yeah, 15 volt. And I is question, so we can find I will be equals to P divided by V. So question number 6b, second part, power is equals to IV. I will be equals to the P divided by the V. I will be equals to 90 divided by 15, and I will be equals to 6 ampere. 6 ampere. 6 ampere. I will be 6 ampere. And by this question, we have reached the end of this section A. So my dear students, today we have done October, November 2022, Physics 505422, Section A of this paper in this video. The Section B of this paper, I will make the video on the Section B also today, and I will upload in my YouTube channel in the same playlist where you have found this. You will be able to find that. So I hope this paper will help you. If you find this video useful, if this video is making your life easier, if this video is making your physics all hours paper practice easier, please subscribe my channel. Also like this video. Also share the link of this video with your friends, with your brothers and sisters, with your junior students, with your senior students, with your teachers. When you do this, this helps me also to promote my channel. So thank you very much, and special thanks to Lahore, special thanks to Karachi, and special thanks to Dhaka, because from there, these are the 3 big cities from where the most of the views are coming. And also special thanks to Aisha Akil. She's my student, and she basically solved this paper, and then I supervise that paper when she's solving it, and she helps to solve this paper. So thank you very much, everyone who are making possible these videos. Thank you very much, all the viewers. So have a good day, sir. And I think it's a blessing for me that I can make these videos. So have a good day. God bless you all.